Hello, welcome back to Learn Physics. In today's topic, we are continuing with our human eye and the colorful world. Okay, in last video we finished till the atmospheric refraction and the some natural phenomena that which we can explain through that atmospheric refraction also we learned, isn't it? Twinkling of stars, early sunrise and delayed sunset, all those things we learned, isn't it? So today we are going to study about the new thing which is scattering of light. Scattering of light. See, what is meant by scattering? When the light rays are incidenting on some particles of matter, it will be redirecting in different ways. That is redirecting, that is scattering. What is the word meaning scattering? Scattering means it will be moving in different direction, isn't it? A particle will be scattered away. That means it will be moving in different directions. Scattered. If a ray of light is incidenting on some particles of matter, it will be scattered in different particles, different directions. So that is called a scattering. Scattering means redirecting the light ray when it is incidenting on some of the particles of matter. That means, see here, many times we would have seen that scattering. See, if you imagine you are inside a closed room, okay, and it is a very dark room and a small hole is there. Okay, so inside the room it's very neat, everything will be neat, but some dust particles or some small particles will be there, isn't it? So when the light ray is passing through that small hole, you can see the passage of light, isn't it? Path of light is visible. That is visible because of scattering. See, we know the atmosphere is a heterogeneous mixture. That means it consists of particles, big particles, small particles, dust particles, water droplets, many things are there in a atmosphere. It is a heterogeneous mixture, isn't it? So many particles, a mixture of many particles is atmosphere. So when the light ray is incidenting on these heterogeneous mixture, as per the size of the particle where the light ray is incidenting, it will be scattered. Okay, depending on the size of the particle. Okay, it's very important. So scattering is explained with the help of Tyndall effect. What is this Tyndall effect? Tyndall effect means when the light ray is incidenting on small particles, size is small in size, then it will be scattered shorter wavelength. Shorter wavelength light will be, wavelength is represented by the symbol lambda. Okay, so the light ray which is having shorter wavelength will be scattered in with the small particles. So if the size is increasing, as the size is increasing, if it is big particle means larger wavelength will be scattered. Okay, larger wavelength of light will be scattered if it is big particles. If it is small particles, shorter wavelength will be scattered. And if it is very big in size, and it won't scatter. That is, we can see it as a white light only. So usually it will be visible as a white light only, isn't it? When we are coming near to the atmosphere, when we are coming near to the earth, it's more size of the particles will be more, isn't it? Dust, smoke and fog, all those things, because of that size will be more, isn't it? So our pollution, because of that and all, size will be more, so we will be observing usually as a white light only. Okay, so this is called as Tyndall effect. So using this scattering, we can explain the phenomenon of blue color of sky. Blue color of sky can be explained with the help of this scattering of light. So what is the reason for blue color of sky? So the light rays which is coming from the sun is passing through the atmosphere. So while it is passing through the atmosphere, what will happen? It will be getting scattered with the smaller particles, and the shorter wavelength will be, which is having shorter wavelength, blue color has shorter wavelength, that will be getting scattered. Okay, so we will be, while we are observing from here, we can see the color as blue. Okay, so you can ask only why it is only shorter wavelength, the small particles, whether big particles are not scattered. Big particles are also there and all we will be observing which color? White color. And where and all we are getting it as from smaller particles scattered light, when it is reaching to our eye, we will observe it as blue in color. So atmosphere, sky will be blue in color. In which and all timings the sky will be blue in color? See, in the daytime, isn't it? If it is early morning, or in the evening while we are observing the sun, this horizon, which color it will be? It will be red in color, isn't it? So here, and see, in the early morning, we know the sun will be at the east, or in the evening it will be at the west. Okay, compared to the other positions, in the morning time and evening time, the sun rays has to travel more distance. Larger distance it is traveling compared to the other distance. Okay, it is coming from a larger distance, and it is moving through a thick layer of atmosphere. Okay, it is moving through the thick layer of atmosphere and larger distance. That is why, so if it is traveling larger distance, what will happen? Smaller wavelength will scattered away there itself, and it can't reach because it has very small wavelength. Blue has very small wavelength. In VIBGYOR, see, this violet, indigo, blue, green and all very smaller wavelength. Yellow, orange, red and all, it is of larger wavelength. So what will happen? All these smaller wavelength will be getting scattered off there only, and we can't see that. Scatter in between and it will go off. But the larger wavelength, which is like a yellow, orange, red and all, will scatter, and in this traveling in this much of distance, it can reach to our eye. So we will be observing the horizon in red color or the sky in red color because of this reason. It is traveling for longer distance, and the thick layer of atmosphere it is traveling. That is the reason. While traveling in longer distance, what will happen? Shorter wavelength light and all scattered off there only, and we can't see it. Before that itself it is getting disappeared. So the longer wavelength will be reaching to our eye. So that is the reason. The same reason we can explain for why the traffic signal is red in color. Stop. Always to stop the signals. If any danger is there, danger symbol is there, we will give it with a red color, isn't it? So in highways and all, in between they will be keeping that red sparkling lights, isn't it? What is the reason? Because this red color means we can observe it from the far away distance, isn't it? When we are coming from far away also, we can see that red light very clearly. What is the reason? Because its wavelength is more and it won't get scattered off, that's very fast. Okay, so that is the reason. We can see it very clearly from longer distance, this longer wavelength light. Okay, that is the reason we are using this red color as our what is that? As our signals, road signals and all, we will be using this red color. So now you understood why we are using blue color, or why we are seeing the sky as blue in color. So if suppose see, we are observing from here, so we are observing the sun, the sky as blue color. So while we are going in the high altitudes, or if the space travelers, how they will be observing the sky? See, they will be observing the sky as dark in color. What is the reason? Because there is no atmosphere, isn't it? So the sun rays won't be getting scattered off there. So they will be observing the no scattering will be happening at that place. It is the reason they are observing the sky in dark color. Okay, that is also another important question. Okay, blue color of sky and red color of the sky in the evening and morning session. So all those things because of scattering. In scattering, you should remember small particles will be scattered off with the shorter wavelength and bigger particles means longer wavelength. Very big means it will be white in color. It will be observed as white in color. Okay, so clear. So this is the small portion which was left out in the previous in this portion, and only one experiment is there. So I will tell you that experiment also. Okay. So to explain this longer, as distance increases, I told you the blue colors and all will scattered off and the longer wavelength will be coming to the other side. To observe that one, we are doing one activity. See here I am keeping one source of light and one convex lens, and the light from the convex lens will be falling like this, and here I am keeping a beaker which has clear water. Okay, so the light ray will be passing through this, incidenting over here, and here again I am keeping one screen, wooden screen with a hole. A hole is there, so the light ray will be passing through this one. Okay, the light ray will pass through this, and which will be again incidenting on a lens, and this is caught on a screen. Okay, this is, so here we can, we can do little bit more, which will be observing over here. Okay, like this it will happen. So it is clean water. I kept it over here. I am adding sodium thiosulfate inside this. Okay, sodium thiosulfate. Here white light is coming, white light was coming and converging, and here it is through the hole, it is observing here. Okay, sodium thiosulfate I added in this, and again so with the clean water I added sodium thiosulfate. Okay, and along with that I added concentrated sulfuric acid also. So what will happen? Sodium thiosulfate and concentrated sulfuric acid will react, and here sulfur will be forming. Okay, when sulfur is forming, what is happening? Small particles are there, isn't it? So these white light is falling on this small particles. So while we are observing from this side, see this side I can see some blue color. Why? Because the scattering is happening in the small particles, and I can observe it as blue in color. That water, this region will be blue in color, like that I am observing. Now, when I am seeing from this side, after the hole, when I am observing, I can see the red, orange, red, all these colors I will be observing from here. Here I can observe the blue color. So it is very nearby distance. Scattering, it is happening in a shorter distance. So I can see the blue color very clearly. As the distance increases, what we can see? We can see orange, red, crimson red, all those colors we will be observing. That means as distance increases, what will happen? Shorter wavelength will scattered away, and we can't reach that, they can't reach to our eye. As the distance increases, only the higher wavelength will be reaching to our eye. Okay, this is what happening in the case of yes, morning and evening. Why we are seeing the sky in red color? Okay, horizon will be red in color. What is the reason? Because it has to travel more distance, so it will be observing it as red in color. Okay, clear? Because through this activity I think it will be more clear for you. Okay, so that's all for today. This is the theory portions in that chapter. Okay, so in next video we will be doing the exercise questions, and some of the rest of the questions we will be doing in the next video. Okay, so if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.